Greetings. I'm Mike Gruntman, Professor of Astronautics in the Viterbi School of Engineering at the University of Southern California. Today we have a very special lecture. 50 years ago, in October of 1957, the first artificial satellite of the Earth was launched into space. This first satellite, Sputnik, was followed by the American launches of the Explorer, Vanguard, and Atlas. The space age has begun. This year there will be a number of conferences, publications, symposia, workshops commemorating this event. These conferences would occur in the United States and abroad. In addition, many materials will appear in the mass media. We wanted to tell our engineering students about the history of this wonderful achievement of science and engineering. So we prepared this lecture for our engineering students enrolled in the honors program. I'm very pleased that the Distance Education Network of the Viterbi School of Engineering decided to make this lecture available to a much broader audience, actually to all those interested and fascinated by space. So this lecture will also demonstrate the technology, the state-of-the-art of the distance education technology. Our distance education network is among largest in the country. So you will see me standing here next to this monitor showing the PowerPoint slides. In addition, I have another monitor in front of me that I can see the same slide. On your computer screens, in a separate window, you will see the same slide captured in high resolution. So we're all set and ready to go. Let's start the countdown. 4, 3, 2, 1, and liftoff. The road to space, the first 1,000 years. So again, let me just say, if you introduce myself, as I said, I'm a professor of astronautics and I'm chair of the Astronautics and Space Technology Division at the Viterbi School of Engineering. We are an independent academic unit as a department. We offer a full set of degrees, Bachelor of Science, Master of Science, Engineer, and PhD in Astronautical Engineering. We are the home of rocket science in the Viterbi School. This lecture is in part based on the book Blazing the Trail, The Early History of Spacecraft and Rocketry. The American Institute of Aeronautics and Astronautics, AIAA, published this book in 2004. Last year, the book received an award from the International Academy of Astronautics. All right. If you are interested in more details, you look for more information or for references to primary and secondary historical sources, the book is a very good starting point for you. The book has a website where you can find more details about it, and the URL is astronauticsnow.com/blazingthetrail. Astronautics Now is one word and Blazing the Trail is one word. All right, this is all for preliminaries. So in October of 1957, the first satellite was launched. How did we get to this point? It is important to know that a story of the breakthrough to space is to a large degree the story of development of rocketry. So let's look at the rocketry and go 2,000 years back. Okay, the ancient Greeks were the first to observe the principle of rocket propulsion. It was 2,000 years ago. They built a special device called Hale. This device consisted of a vessel, and a hot water vapor was exiting the vessel through two pipes, or the nozzles, that are attached tangentially to this sphere. So it was a device producing rotary motion. The Greeks observed this phenomenon, but they didn't explore it further, and they did not go into real applications. So now fast forward 10 centuries in the future. Please, next slide. We're going to China. in around the 11th century. The Chinese are usually credited with the building and creating the first rockets. These were solid rockets using gunpowder as a propellant. The first rockets were attached to the arrows shot from regular bows. Historically, the arrows were at first used as incendiary weapons with some inflammable material attached to the tip of the arrow. Well, at some point in time, there was an improvement in this device, and the rocket device was attached to the arrow shaft, allowing increase the range of arrows. So this was the first application of rockets. So there was a small rocket here at the tip of the arrow, and the shaft served to stabilize the flight. When exactly it happened, we do not know. All the historical records are saying that sometimes it's around 11th century this might have been in place. One of the reasons that we don't know the exact date, even if we have historical records, is that the language or the words that we use in languages are changing its meaning with time. In Chinese, the rocket literally means fire arrow. When exactly the meaning of fire arrow was changed from an arrow with an inflammable tip to an arrow propelled by a rocket, we do not know. But what we do know that definitely in the year 1232 there was a major battle at Kaifeng Fu where rockets were used on a large scale. This Chinese city, defendants of this Chinese city used rockets to repel invading Mongol troops. Actually, it were Mongol troops in service of Chinese rulers of the city who were using the rockets to fight off invading troops. So the Chinese rockets, after that time, used on a wide scale. The rockets remained relatively small. The powder section was only a fraction of a foot long, and the bamboo shaft was only from 1 to 2 feet long. The range was from 300 to 400 yards. So the rockets remains rather primitive. However, the Chinese developed multiple launchers. So the Chinese launchers could carry up to 100 of individual rockets. They could be operated by 1 or 2 soldiers, but the rockets itself, individual rockets, remains rather primitive. In contrast to that, India, as we will see later, would develop much bigger and more sophisticated rockets. The next slide, please. So who was the first? We really do not know who was the first to build rockets. But most likely it happened either in China or India. But the Chinese records, existing records, are the oldest. Now, one of the reasons that India and China were in the best position to develop rocketry was availability of saltpeter. Now, the earlier rockets were operated by used gunpowder as propellant. Gunpowder consists of charcoal, saltpeter, and sulfur. All these materials were known for centuries. So if you go to the Old Testament, you would find sulfur, brimstone, and you can find saltpeter, the meter there. However, in China and India, saltpeter is readily available in many places. In Europe, only very few places have saltpeter, and that is why the China or India most likely were the places where the first rockets appeared. So the Mongol troops in the 12th, 13th century defeated Chinese, and they adopted the Chinese rocket technology. From that moment on, the Mongols carried rockets to other parts of the world. This was the first wave of the proliferation of rocket technology. It is known that the Mongols brought rockets to Japan in 1274 and 1281, and in both invasion attempts, rockets were widely used by them. The Japanese did not pick up the new technology. Actually, they didn't pick up gunpowder even. And the Portuguese would reintroduce gunpowder to Japan several centuries later. Also, the Mongols took rockets to Java, to the Near East, and even to Europe. There are historical records that there was a battle of Legnica in 1241. This is in the modern Poland, where the Mongol troops used rockets. So the Mongols learned the rockets from the Chinese. Did then they brought the gunpowder and rockets to the Near East and taught Arabs and the Europeans? Not necessarily. Not a single country had a monopoly on burning and exploding things. If you look at the Byzantine Empire in Europe, then they used the so-called Greek fire, highly incendiary substance, for many centuries before. It was known since the 6th or 7th century. And then a Byzantine scientist and philosopher, Marcus Gracchus, described gunpowder mixtures and incendiary and explosive projectiles as early as in the 9th century. So the technology appeared, the rocket technology, gunpowder appeared in many places in the world, and finally the events are converging to the real use them as efficient weaponry. The next slide, please. So in Europe, the rocketry slowly took ground. A facility to research in saltpeter was established in Paris in 1227. Then the French army of the Seventh Crusade met with some rocket-propelled devices at Damietta. This is in Egypt. And in Europe itself, the rich Italian cities such as Venice, Genoa, and Pisa led the European technology development. And they benefited with a constant interaction with Europe and with the Byzantine Empire and the Far East in their trade. The first use of rocketry in the European warfare is recorded in the year 1379 in Italy. This figure shows how these rockets were used, and the rockets were already in the shape that would stay with them for many years. A rocket propellant device at the tip, and then a long stick to stabilize the flight. So if you ever use rocket, don't fire when you're in this position. This is only for aiming. Just make sure that you step aside when you fire the rocket. Next slide, please. Now let's go to India. India knew rockets from the ancient times, and India may have been a place that developed rocketry at the same time as the Chinese. So if we look at the historical records, we will see that the great warrior Timur, or Tamerlan, who invaded India, wrote in his memoirs that in a famous battle near Delhi in 1399, he met the opposing forces of the Indian Sultan Mahmud. And these forces included, as Timur wrote, 125 elephants covered with armor, most of them carrying howdahs. It's such cages on top of the carriages on top of the elephants for people. So they carried howdahs in which were meant to hurl grenades, fireworks, and rockets. By the mid-18th century, the Indian warriors widely employed war rockets. Saltpeter was abundant in the country. Bamboo sticks made excellent guiding sticks. And also rockets didn't require bullocks or elephants to pull them. Artillery, in contrast, required these huge animals to pull the heavy pieces through the very rough terrain. And in addition, artillery in India in those days usually was serviced by European officers from all countries of Europe, and it cost a lot of money. Rockets, in contrast, could be operated by native troops with very little training, and that could carry them across the rugged terrain. Now, in a major development for rocketry, Mysore rulers heavily promote this weapon. Mysore is a state in India in the middle of the subcontinent. Hyder Ali, the ruler of Mysore established a 1,200-man-strong racketeer force. It was a huge number for those days. His son, Hyder Ali, increased this force, this dedicated rocket force, to 5,000 men. The Indians also introduced major innovations in contrast to Chinese. Chinese rockets, as we said, remained very small and efficient, but Chinese developed multiple launches. So the Indian rocketry introduced metal cylinders to contain the black powder, metal cases. Even primitive metal cylinders could contain much higher pressure of gas inside the rocket cases as compared to the Chinese rockets made out of paper. So this higher pressure allowed higher thrust, longer range, and more heavier rockets. And indeed, the Indians developed rockets with mass up to 12 pounds, and the range reached on occasion more than 1 mile. So rockets remained highly inaccurate, however, and unpredictable, but they served as an efficient incendiary and terror weapons. What happened next? The events taking us to Europe. The British got under very particularly heavy rocket attack from Indians at 2 battles near Seringapatam in 1792 and 1799. This was the capital of the Tipu Sultan state. So rockets were used against British on a very large scale. As an example, when Seringapatam was captured by the British troops, among trophies were 10,000 war rockets. Again, we're not talking about a few pieces of rocketry. It's thousands of war rockets. So they were used on the routine in a routine fashion. So these Indian rockets hit, quote unquote, an unintended target, a British inventor, William Congreve. So the reports coming from India alarmed a number of people in Europe, and Europe was bracing for the wave of major wars with the rise of France of Napoleon. So William Congreve, a British inventor, started to develop a family of new rockets. And he was the first who really developed a real efficient and effective military system, as weapon system of rockets. The rockets of various sizes, but he standardized their design and their operations. The first British rockets were successfully used in 1806 in attack against the French city Boulogne, and then in 1807 the Royal Navy, using rockets, burned down to ground Copenhagen, the capital of Denmark. These rockets became known as the Congreve rocket. The Congreve rocket design was typical for those time. It consisted of a warhead, then a gunpowder grain with conoidal chamber, and a base plate with an exhaust orifice here. Then in addition there was a long guiding stick to provide stability of flight. So these Congreve rockets, as I said, they formed the first truly military system of weapons, system of rockets, and the rockets range from a small 6 pounds only to as big as 300 pounds. And this figure shows you the variety of rockets. A lot of tools were introduced, standard tools to service them. There was also small rockets on a parachute to provide lighting, and some of those old rockets are preserved, and you can find them in museums, as this 100-pound Congreve rocket shown. So these rockets were used from various platforms. The Royal Navy was firing them from the ships, and they were very effective against wooden ships and sails on them. They were also fired from the ground. The army used them. And in addition, and a very important development, the rockets could be fired from a small boats, like shown here. If you try to fire a cannon from a boat, the recoil would capsize the boat. However, rockets don't have recoil. They don't require anything to push against, and they can be fired from a small boat, allowing to go to shallow waters with these weapons. The same feature of rockets, lack of recoil, allowed them to be introduced as early as in 1916 on airplanes. Airplanes also wouldn't like strong, severe recoil, particularly the early airplanes of the World War I. So the rockets were used for the first time successfully in 1916 on airplanes. Now there was a major technological advancement. In 1815, the new design was developed that allowed to have centrally mounted guiding sticks. So instead of attaching stick to the side of the rocket, now a special base plate was made. A special base plate was made with the central threaded socket in the center, and you would take your guide stick and you would screw it in, and the holes surrounding this central threaded socket would serve as nozzles. Usually 5 or 6 of them were used. This is a contemporary drawing of such a rocket. Having a centrally mounted guiding stick allowed launching of rockets from tube launchers that improved dramatically their service in the field. Next slide, please. So, rockets coming to America. The war between the United States and England started in 1812, and the British troops, British Navy, and the Marines on the ground brought rockets to North America. At first, the rockets were heavily used by the British Royal Navy, burning American coastal towns in New England. On the ground, the British troops advancing towards Washington met with American forces at Bladensburg near Washington. This was August the 24th of 1814. By blunder, 3 Baltimore regiments of militia were moved into an entirely uncovered position, and by the way, one of the politicians in Washington who probably shouldn't be on the battlefield came there and gave this enlightened advice. So the British fired rockets at the exposed regiments, and 2 of them broke and fled in the wildest confusion. The battle was lost, and the rockets played the most important role in that, and the British troops marched on the same day to Washington, occupied that, and burned the Capitol and the President's house. So the next slide, please. Only 3 weeks later, the British troops pushed towards Baltimore, and the British Navy tried to get to Baltimore also, but the access to Baltimore was guarded by Fort McHenry. So the British fleet bombarded Fort McHenry, and among those bombarding ships was a special rocket ship of the Royal Navy, HMS Everett, that fired numerous rockets. Everett was injured by the return American fire, and it had to be towed by small boats to safety. This was exactly the rockets, these concrete rockets that were bombarding Fort McHenry, that were observed by Francis Scott Key, who later wrote his famous verse, "And the rocket's red glare," and finally this verse became the American national anthem. So these were the concrete rockets that we have in our national anthem. Next slide, please. So the United States Army Ordnance started experiment with rockets on small scale after the War of 1812. And the rockets were, as we would say, the back burner until the war and the invention brought them into light. The war was the war with Mexico that broke in 1846. Also, a approximately at the end of that year, in December, William Hale, a British inventor from London, found a way how to stabilize rocket flight without a guiding stick. He proposed to use a spinning of the missiles, and the spinning of the missile was achieved by tilting the exhaust nozzles or orifices. So the exiting gas provided thrust, but also it provided some torque to spin the rocket projectile. In his homeland in Britain, the invention of William Hale was not accepted by the British authorities, so he came to America to sell it. And the American Navy and Army, in a joint effort, purchased from him this invention. Within 3 months, prototypes of his rockets were built in the Washington Arsenal. And Washington Arsenal was almost in the downtown Washington, D.C. as we know it today. Today it's National Defense University is located there. So within a few months the rockets were built, successfully tested, and the mass production was started at the Washington Arsenal. Within 6 months, more than 2,000 rockets were made, and they were sent to an exhibition to Mexico. It is an amazing story of a procurement. Within 6 months, jointly the Army and the Navy procured a new weapon system, developed and put it in the operation in the field. There's some contrast what we can observe today with the current procurement. So to service rockets, the first American rocket military units were formed. A special howitzer and rocket battery, more than 100 men, was activated in December of 1846. And the battery landed near Veracruz in Mexico with the army in March of 1847. It's interesting that during the siege of Veracruz, the Mexican forces were first to fire their Congreve rockets against the Americans. And then on the night of the 24th of March, the American rockets were fired for the first time in the military operations. During the campaign, Mexican campaign later, the rockets were fired many times and sometimes very successfully. So this was the beginning of the American rocketeers. The experience with rockets was not really that good. They were not accurate. There were premature explosions, problems in the storage. They deteriorated and they were unsafe. So the army was not happy with them. And the rockets remained on a very low level in the American armed forces after the war. During the Civil War, the rockets were really very rarely used. There were only a few instances, so the rockets were not very popular. So the 19th century witnessed the second wave of proliferation of rocket technology. So this map shows this large red dots show the countries with the large rocket developments. It's the United States, Russia, France, England, Austria, Denmark, Sweden, and other countries. And the small blue dots show many other countries that developed rockets and used them. It's interesting that while the first large-scale use of Congreves after the British pioneered them in the war with Napoleon was not in enlightened Europe, but it happened in Chile, which was a young republic just formed, fighting for independence against their Spanish rulers. In 1819, Chilean Navy used a large number of rockets in attack on Spanish shipping at Callao. It's a port close to present Lima in Peru. Well, Chileans tried to save some money, the government of Chile, and they forced the prisoners of war, Spanish prisoners of war, to get involved in fabrication of these rockets. And these prisoners remained loyal to their country, and they basically sabotaged this effort. Whenever they could, instead of gunpowder, they inserted in the rockets sand, horse manure, all kind of stuff. So about 10% of the rockets only performed properly. Others were others malfunctioned. But this was the first case after the British used rockets very widely during the war with Napoleon. So many countries used rockets, particularly the Great Britain and Russia. And they used these rockets for a long time until the end of the 19th century. And most of the use of these rockets were in colonial wars against poorly trained and poorly trained troops of their adversaries. Now there was also use of rockets between major countries, like in the Crimean War in 1853 and 56. Both the British and the French used rockets against the Russians, and the Russians retaliated with their own rockets. So the rockets were used pretty widely through the 19th century. The next slide, please. So the rocket technology also improved during the 19th century. Well, first of all, a centrally mounted stick was a major improvement, as we discussed. Then the rocket spin by stabilization, introduced by William Hale. In addition, the stabilization by fins was tried, but was not really as successful. Another major improvement came from the same William Hale, and this was hydrostatic press to ram gunpowder in rocket cases. Before that, people use special ramming mallets and monkeys. Monkeys is some weight that you drop and just goes down and hits something with the precisely determined thrust or impulse. Of course, using mallets or monkeys was unsafe. It created a lot of put a lot of particles of gunpowder in the air, and the explosions were not uncommon, and people were dying in the manufacturing of rockets. So the hydrostatic press was a major improvement. There were other improvements in the rocket design and applications, and one of the most unusual application was a special submarine built by the Russians in 1834. It was a very secret project in Russia in those days, and this ironclad submarine was 20 foot long. It has a crew of 10 men, and 2 rocket stands could fire 3 rockets each from a submerged position. So it was a pretty amazing development. Unfortunately for rockets, artillery won the competition against rocketry, and the rockets almost disappeared from military use. Why it happened? There was a major advancement in artillery in the 19th century. First, rifled barrels. Rifled barrels allowed to spinning up of projectiles which achieved superior accuracy of artillery. Then breech loading improved firing rate, and then the new types of steel produced mostly by the Bessemer steel process allowed building stronger barrels, and stronger barrels meant higher pressure inside the barrels and improved range. So all these 3 factors really made artillery highly superior compared to rocketry. In addition, new steam-powered ships had some armor to protect them, and they didn't have sails, and the rockets were very effective in the past against wooden shipping. So for naval applications, rockets also lost their effectiveness. Rockets remained in the entertainment, fireworks, and in the whaling industry by the end of the 19th century. The next slide, please. So the interest to rockets among the military dramatically diminished. At that time, the man of plume replaced the man of sword as the keepers of the public interest. Well, space travel could be found in fiction writings or science fiction writings, as we would say today, for many centuries. But the second part of the 19th century saw a tremendous increase in such writings. And of course, nobody captured public imagination more than Jules Verne by his wonderful stories. His classic novel, De la Terre à la Lune, From the Earth to the Moon, was a seminal work on spaceflight. And Jules Verne's work motivated those special kids that would later become visionaries and the main drivers in the space age, such as Tsiolkovsky, Goddard, Everett, Pelterie, von Braun, Glushko, and Korolev. The next slide, please. It's interesting that science fiction literature described space travel in the 19th century, and the characters in those novels attempted space travel for various reasons: for fun, for curiosity, as a bat trying to escape death or nagging wives, but they never did it with a practical, useful goal. So in 1870, a most inventive author, Everett Hale, published a story, The Brick Moon, and this was the first story which described something of practical use. Everett Hale came from Massachusetts, and he saw the tragedies of men being lost at seas during bad weathers when they were losing without navigational aids. So he reasoned in the following way: if we have our real moon in the sky that allows us to determine latitude of the observer, why don't we put an artificial moon in a polar orbit, and this artificial moon would allow sailors to determine their longitude. So this was an idea to have a navigational device, to have an application satellite for practical purposes. So the characters in Everett Hale's story, they started to build a huge satellite out of bricks, and then by mishap this satellite, unfinished, was launched into orbit, and some people were trapped on it. So they were staying in orbit for a long time, and there was even, so it was the first description of an orbital space station. And it was interesting how the people on this artificial moon, on the brick moon, how they communicated with the ground. So the people lined up on the surface of the moon, and some of them were jumping and others were standing on the ground. And those jumping meant dashes of the Morse code, and those standing dots of the Morse code. So it was an interesting story. The first application satellite, and the monument to Everett Hale can be found at the Boston Commons, and very few people know his real contribution to rocketry. The next slide, please. After that, let's talk about the four great space pioneers. The first, they're coming from different nations. Their contributions are different, but all four of them provided indispensable contributions to bringing us to the space age. The first is Konstantin Tsiolkovsky, the Russian. He had visionary writings and about space, and these writings inspired the generations of space enthusiasts. He never built things, but he did some theoretical work. The second great pioneer is Robert Pelterie, the French. Pelterie was also a famous aviation pioneer. He invented or introduced the joystick to control airplanes, and the ailerons and safety belts and other things. He was an accomplished engineer, and because of his fame as an aviation pioneer, what he was writing and doing in the area of space and rocketry was accepted by the mainstream science. In those days, space pioneers were considered by the public at large as basically nuts, talking about some crazy things. It was Robert Pelterie who did, perhaps more than anybody else, for bringing the pursuit of spaceflight into the serious scientific and engineering mainstream. His first article on spaceflight was published in 1913 in a regular physics archival journal, Journal de Physique in France. He also introduced the word astronautics as a word of science language. And of course, we have an American, Robert Goddard, who did a lot of theoretical and experimental work. He was the person who built the first liquid rocket. And the fourth was Hermann Oberth, who it's very hard to say where he is coming from because he was born in a part of Romania populated by Germans as a part of the Austrian-Hungarian Empire. And but finally he became a German citizen. It's around 1940, 1941. He published an influential book in 1923 about space, and many important concepts in propulsion and rocketry originated there. The next slide, please. I want to say a few words about Robert Goddard. So he built the first liquid rocket ever, and this rocket flew on 1926, and the maximum altitude was only about 40 feet, and it flew in a range, downrange 184 feet only. Now, Robert Goddard had a PhD in physics, what we will call a solid-state physics now, and as a scientist he approached rocketry in a very consistent, solid, scientific manner. And he was supported in his work by several institutions, and at one occasion he published a report on his experiments, and in this report he calculated how much delta V or velocity is needed to put the rocket to a certain altitude, and he mentioned there about his calculations how much would delta V would be needed to reach the moon. And the moon part got attention of the media, and he was viciously attacked and ridiculed, and perhaps the most severe attack was by the New York Times in its editorial. And the New York Times wrote that, the quote is here, that Professor Goddard does know the relation of action and reaction and of the need to have something better than a vacuum against which to react. To say that would be absurd. So basically Goddard's statements that the rocket would work in vacuum was attacked by the New York Times. Later, New York Times sort of apologized. It was 1969. It was on the day when the first Apollo mission to land man on the moon was already on the way to the moon. And this sort of apology actually was spinning the story and implied that, well, in 1920, when New York Times attacked Goddard, it wasn't really clear whether the rocket would work in vacuum or not. So, which is obviously not true. It was known for many years before that. But anyway, this media attack on Goddard had a very significant consequences. Robert Goddard became highly seclusive after that. When he moved his experiments to New Mexico in 1930s, he did not interact with other rocketeers of the emerging American community working in rocketry. He kept to himself, and again, it was a tremendous loss for the country and for the rocketry that Goddard, after this severe attack by the media, did not interact with with his peers in other rocketeers. By 1937, Goddard's rockets reached 9,000 foot altitude, and he had more than 200 patents in rocketry. The next slide, please. So the first modern rocket was built in Germany during World War II. The development started in 1930, actually, by the German army. And this was a major state-sponsored effort, modern effort, modern in the sense that the big organizations are involved in contrast to individual rocketeers. So it was a major effort by nationalist socialist Germany, and it was led by Walter Dornberger and his key technical engineer Werner von Braun, or von Braun. The rocket that was created, called A4, it is also known under the name V2, V2 from the German word for vengeance, Vergeltung. It was truly a technological marvel. It carried a warhead up to 2,000 pounds to a range up to 180 miles. its specific impulse at sea level reached 210 seconds. And not only technical characteristics of the rocket shown here were really tremendous advancement. The manufacturing problems were solved. It's not just a few rockets were built. The Germans succeeded to build almost 6,000 V2s, and more than 2,000 out of them were operationally fired, mostly against London and Antwerp, a port in Belgium. During the production of V2, slave labor from concentration camps were used, and a lot of people died, particularly by constructing underground facilities to manufacture the rockets. And the conditions were really savage there, and up to 6% of concentration camp prisoners working there dying every month. The next slide, please. In the United States, during World War II, the rocket development was on a smaller scale, obviously, than in Germany, and it concentrated on the very specialized rockets. The organization that was pushed rocket development was the United States Army Air Force, particularly General Hap Arnold, one of the most technologically oriented military leaders. So Arnold contracted a group at Caltech, California Institute of Technology, led by Theodore von Karman. And this group initially started to work on so-called JTOWs, jet-assisted takeoff devices. These were devices, small rockets attached to airplanes, allowing heavy airplanes to lift off from the ground. And here you can see the first such takeoff, rocket-assisted takeoff from Marshfield, California, here in Los Angeles in August 1941. So both solid and liquid propellant rockets were developed. Also composite solid propellants were developed at that time, and the Jet Propulsion Laboratory was formed in 1943-1944. In addition, another event happened, it's a very American event, that the private enterprise moved in, and the first company, rocket company, was created in December 1941, just after the Pearl Harbor attack, and this was Reaction Motors Inc., RMI. And this was followed in March 1942 by formation of Aerojet Engineering Corporation, which is still one of the very powerful companies. Many thousands of solid rockets were built, and they were used from the airplanes, and also were used by the Navy from the naval ships, as you can see here, supporting landing of the troops on the beaches. The next slide, please. So, why the satellite was not attempted in 1930s or even earlier? Science fiction writers were writing about that for a long time before. Well, we have to keep in mind that many technologies were needed to make a successful artificial satellite possible. Well, first of all, you need launch systems, of course, and rocketry was not up to the task until after the World War II. In addition, think about the following. It's not enough to launch a satellite, you want to communicate with a satellite. So radio must be advanced, and radio telemetry, that means transmission of data by radio, was first attempted and demonstrated only in 1932. Then you want to provide electric power for your satellites. Now the solar cells, ubiquitous solar cells now, of practical efficiencies were first demonstrated in 1953, not before. So before that, if you had launched a satellite, you would have used some kind of a mechanical generator concentrating solar power, heating working fluid, and producing electrical power. Then you want to maneuver in space and to maintain attitude, you need the propulsion capabilities. So cold jets were known for some time, but the hydrogen monopropellant, an efficient way to control attitude and to maintain orbit, was developed only in 1962. In addition, attitude control and guidance and navigation are very important, and this technology was advanced really during World War II mostly for the long-range aviation, and after World War II in a guided missile. So it's a lot of advancement were needed. And the last but not the least, an extensive ground facilities were needed to test and launch rockets. So Cape Canaveral was activated in 1949 only, and the main Russian side, Tyuratam or Baikonur, the construction there began only in 1955. Well, actually, it's was in the Soviet Union. Now it's in Kazakhstan, which became a very well-known country after the Borat movie. Now everybody knows where the Tyuratam or Baikonur is, thanks to Borat. So in the United States after the war, there was several groups working on rocketry. And it is a misconception that fills popular writings that it was von Braun and his team that came to the United States was the only place where the rocketry was developed. Yes, indeed, there's German rocketeers, about 100 engineers that were brought to the United States after the World War II played an important role, but only in the rocket program guided by the United States Army. Several industrial locations in the United States and the contracts, mostly of the Air Force, were advancing rocketry. An example is shown here. This is Convair, which started in Los Angeles and then moved to San Diego. Its development was building and developing a rocket MX-774 under the contract of the United States Air Force. This program ultimately led to the development of the Atlas intercontinental ballistic missile. A few words about this later. So what was happening in the mid-50s and gave a major push to rocket development was the International Geophysical Year. The idea was to conduct the International Geophysical Year for 1.5 years from July 1957 to December 1958, and to conduct broad synoptic study of geophysical phenomena. That means making measurements all over the world. So it was an international effort. This time also coincided with the period of maximum solar activity of the 11-year solar cycle. 70 countries participated in the International Geophysical Year, and both countries, the United States and the Soviet Union, announced their intention to launch artificial satellite during the IGY, and both countries succeeded. So in the 1940s and 50s, the Soviet Union and the United States were developing ballistic missiles mostly for military applications, with the increasing capabilities in accuracy, range, and warhead weight. And then International Geophysical Year was announced, that emphasizing the scientific applications. The next slide, please. So the Soviet Union, as we know, was the first to launch Sputnik, or as the Russians would pronounce it, Sputnik. And this first launch originated, obviously, from the purely military application of developing intercontinental ballistic missile, ICBM. So this missile is known as R7. R7. As this is the nomenclature of the Soviet rockets. In December 1950, the feasibility study was authorized, and it required the very heavy warhead, about 5,500 kilograms or 12,000 pounds. Now, the weight of the warhead was determined by the existing technology of nuclear weapons. And the Soviet nuclear program was behind the American program, so Soviet nuclear warheads were much heavier, and because of that, the first Soviet rockets, as we will see in a second, would be much, much bigger than American rockets designed for the same purpose, because again of the technology of nuclear warheads were behind there. So this was the requirement, the warhead of 5,500 kilograms. In May of 1954, the development of R7, the first Soviet ICBM, was declared top national priority. And on the 21st August of 1957, there was the first successful launch of the ICBM. On October the 4th, the same rocket, slightly modified, launched Sputnik, the first artificial satellite. So a number of people were behind this accomplishment in the Soviet Union, and of course Sergei Korolev is considered as the key for the Soviet program. He led the Soviet program. His design bureau built and integrated the first rocket launchers, first space launchers, first satellite Sputnik, and many other Soviet satellites. Another key Soviet rocketeer, Valentin Glushko, was the leading designer of rocket engines, and there was a tremendous rivalry in the Soviet Union from 1940s till 1980s between the two establishments, one led by Korolev and his successors, and another led by Valentin Glushko, but the two of them were really led the Soviet effort. The Soviet launch of Sputnik was followed by the launch of the Sputnik 2, with a dog on board, and because it was rushed in the production, the thermal control system was not really developed, and the dog probably died after 12 or 16 hours because the temperature grew too high on board. The next slide, please. So what happened in the United States at that time? Well, in the United States, three groups were proposing or were capable of launching satellites. The first group was led by the United States Army, and this group was the headquarters were at the Redstone Arsenal in Huntsville, Alabama. It was led by General Medris and Vernon von Braun, and many of these 124 German rocketeers brought to the United States worked there with von Braun. Other groups independently working on the development of rockets was the United States Air Force, developing what would become the future ICBM, Intercontinental Ballistic Missile Atlas, and the Convair was in San Diego was the prime contractor. In addition, the Navy and a couple other industrial companies like Glenn Martin were involved in building bigger and bigger rockets in the 1950s. So there was many places in the United States that were developing technology. Again, to say that it was only this group of von Braun that leading rocket development in the United States is a misconception. Unfortunately, this misconception proliferates throughout many publications. So, which group should be building a satellite to launch during International Geophysical Year? Here we're coming to policy issues. It's not science and technology issues. President Dwight Eisenhower was extremely concerned about a possibility of surprise attack by the USSR. The American society is open society, and American media, they would tell you all secrets that they can put hands on, as we know. The Soviet Union was a closed society, and nobody could penetrate it. Human intelligence was very poor. And the only way to achieve some information about intentions of the Soviet Union was to use overhead intelligence. And again, the Soviet Union, it was a communist country with a very aggressive ideology. So obviously the aircraft is a solution, and the U-2, as we know, flew over the Soviet Union, but these flights were very few in numbers, and with the increasing capabilities of the Soviet air defenses, it was clear that sooner or later the U-2 would be shot down, and this is exactly what happened in 1960. So President Eisenhower decided to develop a satellite reconnaissance system. However, an issue came up here. Is it legal to overfly another country in space? So it was necessary to assert the principle of freedom of space. So therefore, the policy of President Eisenhower was, let us develop a pure science satellite, launch it. And this launch of a purely scientific satellite in a very open program would assert the principle of freedom of space. And after that, reconnaissance satellites may fly over without violating the precedents of international law. Therefore, instead of using either significant capability in Huntsville, Alabama, that the United States Army had, or distracting the United States Air Force from developing ICBM Atlas. The President Eisenhower decided to start the development of a new pure space launcher, which was called Vanguard, and it is not linked to any ballistic program, to a ballistic missile program. It is not linked to any military weapon program whatsoever. So this program should assert the freedom of space. So the program Vanguard was activated in August 1955. It was authorized as part of the International Geophysical Year. So the brand new space launcher was supposed to build in scientific satellites. The Naval Research Lab provided technical direction, and Glenn Martin Company was the prime contractor. And this program has a heritage because the same team built in 1950s sounding rockets called Viking. The next slide, please. So this new rocket launcher was being built, and what happened that the United States Army, John Madris and Werner von Braun, continued to advocate, let's launch a satellite, and they wanted to launch it as quickly as possible before the Soviet Union would do that. And the Army had the capability, and this is the first time this capability really could have been realized on September 20th, 1956. During a test of a special Jupiter C missile, the Army was ordered not to deploy the satellite because the capabilities was there to insert a satellite into orbit, and if it had happened, this would have been the first satellite. Actually, exactly the same that the Army wanted to do in that case would happen later with Explorer 1. So they were ordered not to launch satellite. And then the events started to develop very quickly. On October the 4th, 1957, the Soviet Union launches Sputnik 1, followed on the November the 3rd by Sputnik 2 with a dog Laika. What is interesting that the Soviet launches have asserted freedom of space, and from now on nobody could challenge overflights of other countries in space. So, and it's ironic that the United States was afraid that the Soviet Union would challenge American reconnaissance satellites, and it was the Soviet Union that paved the way in a legal sense for American reconnaissance satellites later to overfly other territories. So Sputnik had a tremendous effect on the world, and it was a powerful weapon in a very sharp ideological confrontation of the Cold War. While the United States government knew about Soviet intentions and the forthcoming Soviet launch, and actually the intelligence community predicted accurately the timing of the launch, the public was, the American public was truly shocked by this Soviet success. And of course this public shock was augmented by media and by politicians, so it's nothing new when we read the newspapers today. When Sputnik was launched, what immediately happened that the United States Army was given green light to try to launch what they proposed to do in 1956. So now two groups, the Navy and the Army, were competing. Vanguard and the Army wanted to launch Explorer. So in December of 1957, in an attempt to launch Vanguard, there was a tremendous explosion on the launch pad, and there was the media again emphasized this mishap. It is important to say that Vanguard was not supposed to be put in space on that day. This was one of the test launches, planned test launches, but because of the events of the launch of Soviet Sputnik, the program was rushed. So finally, on January 1958, Explorer 1 was launched, and it was launched by the United States Army, by von Braun and General Madris. Then on, so the rocket is shown here. Then on 17th March 1958, Vanguard, this originally planned Vanguard, went up for the first time successfully. And in December of 1958, Atlas, the future ICBM Atlas also put a satellite into orbit. Well, with these issues about Vanguard, it's necessary to put it on record that because we have to correct this perception created by the media that Vanguard was an extremely successful program. Think about that. An entirely new space launcher was to put a satellite into orbit only 30 months after the vehicle authorization. So this is a very short development period. The program was tremendously successful. It was unfortunately caught in this public relation events caused by the launch of Sputnik. But again, this was a technically very successful program, and all the bad rap that Vanguard was getting in the media was really not deserved. The next slide, please. Okay, so the first satellites went up. The space age has begun. The first 3 satellites are shown here in scale. So this is Soviet Sputnik. Vanguard was very small, and this is a part that the Explorer 1 in orbit, which consisted of the instrumentation section here, and the second part was the burnout for stage that put a satellite into the orbit. Another important thing that we have to notice, if we put all the first launchers here in scale, you would see how the Soviet R-7 is much, much larger than American rockets. And Vanguard was really a dedicated space launcher for small payloads. What Army launched, Juno 1 or Jupiter C, or the rocket that launched Explorer 1, it was really an IRBM, intermediate range ballistic missile. Only Atlas was the future ICBM, and it should be comparable in its design to R-7, Soviet R-7. And we see that Atlas is much smaller than the Soviet R-7 that put the first satellite into orbit. And as we already said, it is much smaller because R-7 was designed for much heavier nuclear warheads. American technology, nuclear weapons technology, was far ahead, and the requirements for Atlas was about a factor of 3 smaller. The warhead was a factor of 3 lighter than the warhead for R-7. Well, the R-7 evolved in a successful, still operational space launcher, Soyuz. There are a lot of modifications, but it's still putting satellites into orbit. Atlas launched many space vehicles also, particularly in the 1960s and 70s. So, was there a technological gap between the Soviet Union and the United States when it happened? The Soviet Union was the first to place a satellite into orbit in October 1957. By about 14 months later, by December of 1958, the United States launched satellites by 3 entirely independent different launch systems. It would take 2 more years before the Soviet Union would try to launch a satellite by a space launcher other than based on R-7. So basically there was no real technological gap. Technology was there on both sides. The Soviet Union focused on this being first to launch, and they succeeded, and the American response clearly showed that the technological base was here, and that within 14 months 3 independent systems put satellites into space. And the next slide, please, which is the last one. So this flight launch of satellites started the space age, as we said, and other nations followed. Today it's a truly international undertaking or enterprise. France followed in 1965 with its satellite, then Japan and the People's Republic of China in 1970, United Kingdom, Great Britain in 1971. This launch by of the British satellite was the last launch by individual European countries. They formed the European Space Agency, and beginning from 1979, the European Space Agency launches satellites for Europe. Then India joined the Space Club in 1980. 8 years later, in 1988, Israel joined this exclusive Space Club. Well, Brazil tried at least twice to launch a satellite in 97 and 99, and all attempts failed, but the country is determined to launch a satellite by its own rocket, and it will succeed, no questions about that. And the reports are that South Korea is building the capabilities to launch a satellite. So the first 1,000 years of rocketry brought us spectacular successes, and we reached the cosmos. The next 1,000 years, no question about that, will be even more exciting. And the road was not easy, but who said that the road to Alpha Centauri would be easy? Per aspera ad astra, through difficulties to the stars. Thank you.